Surface smoothness,
Hmm.
surface area,
Okay, good.
and what material the object is made of.
Yes.
Roughness of surface.
Roughness of surface, good. Force applied on the objects, right? Force applied
Yes.
on the object. Okay. And lubrication. Yeah. You guys think of some other things also, some other reasons also? Yes.
The amount of surface area in contact.
The amount of surface area in contact. I think that was counted already. One extra thing I did told in the class, it was temperature also, right? Temperature also determines the friction. In certain situation, it increases the friction. In certain situation, it decreases the friction. But it influences the friction. That is the thing. Okay. Lubrication also was there. Yeah. So about the friction in the beginning, what we learned that friction is a necessary evil. We say that it's a necessary evil. Huh? It is a force that will come into action whenever two objects comes into contact with each other, and because of the frictional force, we are able to do different types of activities. Okay. Plus, we did learn that force of friction opposes the movement between surfaces of two objects. Right? It will oppose. How much it will oppose? It will depend upon the nature of the object. It will depend upon the amount of force. It will depend upon the shape of the object also, surface area and contact, lubrication, temperature, etc. Plus, we learned that friction is a universal phenomena that every time, everywhere it will be occurring. Every two surfaces will be interacting with each other, no matter what shape, what size, and what medium is. So friction is always existing. We learned that friction is because of the irregularities between the surfaces of the objects. Okay. Aisha, particularly, you will be getting all those things revised. Okay, no? So particularly pay attention here. Also turn your camera on. So these are the factors that affects the friction. Nature of surface, amount of surface area and contact, type of the motion, if the object is sliding, if it is rolling, or if it is um, basically standing there, or whether it is rolling or whether it is sliding. So that also determines the friction. These are some of the factors. Further, we have learned there are basically three major types of friction. Okay, static, sliding, and rolling friction. In the static friction, the object will be at rest. It will not move. In the sliding friction, the object will be sliding over the surface of another object, basically. Okay. So in the rolling friction, we learned that it's that type of friction which will oppose the rolling of object over another object. That is something which you had learned. Further, we learned that since the object will be at rest, and in the case of a static friction, so thereby static friction have got maximum magnitude. And once the object starts to move, so the type of friction that an object will experience while it will be sliding, that is the sliding friction. It is slightly less than static friction. And when the object will be rolling over another object, so the type of resisting friction that the rolling object will experience, that is the rolling friction which we have discussed. We learned that there are some advantages and disadvantages of friction, like we are able to walk or run without slipping, the vehicles are moving, or we are able to light a matchstick, or we are able to fix the nails on the wall, or we are able to write on a blackboard, or we are able to create heat just by rubbing our hand or rubbing the two objects together. So of these are examples of all of these are advantages of friction. But on the other hand, there are certain disadvantages of friction also, which we have done. Friction leads to wear and tear of objects. After a certain period of time, the parts of the machines or the tires of a vehicle or sole of the shoe, it starts to get damaged. It starts to wear and tear. So thereby, it leads to damage of certain things. It results in production of the heat also. So in the case of the machines, if lubricants are not put into the machines at proper interval of time, so thereby the due to generation of the heat, the parts of the machine might break. That is one thing. Friction uh, can decrease the speed of the moving vehicle. So if the speed of the moving vehicle will be decreasing, so thereby it will waste our time, right now. So our time will be wasted. Plus, if the parts of the machines become rusty, if the engine of the car or some automobiles basically is rusty, lubricants have not been put into it, so it will consume more fuel to run, isn't it? So that is one thing. Further, friction, like many times we hear the sonic boom when the jet crafts, particularly when they travel at a speed more than that of sound, when they reaches a speed more than that of the speed of sound, thereby they produce a loud sound called as sonic boom. So that is also because of the frictional force. So as this jet craft is moving in the air, so it will be experiencing air resistance. The air molecules will offer resistance to it now. So because of that, sonic boom is produced. Further, frictional force leads to forest fire also. It leads to wear and tear of parts of the machine, as we have learned, and leads to noise pollution also. Then we did learn how we can reduce or increase the friction. So whatever factors, like we can increase the friction by roughening the surface. We can make the threaded patterns on the tires of the vehicles. We can increase the surface area of objects or remove any kind of lubricants, or we can increase the force that is being applied on an object, or instead of rolling friction we can use the sliding friction. So these are some of the ways how we can increase the friction. In order to reduce the friction, we can use lubricants like oil, grease, or dry graphite powder. All of these can be used as a lubricant. Also, if the object is rough, we can smoothen it with the help of a sandpaper to make it smoother and reduce the friction. We use ball bearings in the vehicles to reduce friction, and that helps in the movement of the vehicles. All of these were some of the ways we have learned. We did learn about the fluid friction also. In fluid friction, particularly, we had learned that it comprises internal and external friction. This is something which we were discussing in the previous class, in which I told you. By the way, fluid basically now, uh, fluid, what does it refers to, Ibrahim? When we say fluid, what does it mean?
Like fluids like
And
water, gasoline, petrol, diesel.
mm, yeah, not only liquids but the gaseous substances also. So they are the fluid, right? So whenever a fluid, when we talk about the fluid friction, so the fluid friction means that suppose our airplane is moving in the air, right? So air is a fluid and it will offer some resistance to the airplane now. So that will be fluid friction there. When we are swimming in the water, or when the ships or the submarines are moving in the water, so water will offer some resistance now. Water will offer some friction. So that is also a type of, that is also fluid friction. So fluid friction basically refers to the friction offered by the basically the friction that an object will experience when it will be moving in a fluid, right? That is one thing. So the fluid exerts a fluid friction upon the object whenever the object will try to move across it, whether it be in water or whether it be in the air. So that is something which we have learned. And fluid friction depends upon several factors. Okay, it will depend upon the speed of the object. So if the swimmer were to swim faster, he will experience more friction. Okay, and it will, the fluid friction depends upon the nature of the fluid also. Nature of the fluid also. So suppose if the fluid is more denser, fluid is more dense, getting it now. So thereby the friction will be more. Okay, friction will be more. Okay, you guys know about the Dead Sea?
Yes,
Where is Dead Sea? It is in, like, what is special about the Dead Sea?
you
Yeah,
can't uh, you can't drown in it because the amount of salt in it.
yeah. So the amount of salt in it is unlikely very high. So the density is of that water increases too much. It is more than our body. It increases as compared to our body. The density becomes more. Hence, the person is able to float and not sink in that. So thereby the thing is now that density will also influence the friction. That will also influence the filtration. So there are several factors which affects the fluid friction, which we have discussed. Like we have learned about the speed of the object that will be moving in that fluid. If a swimmer were to swim faster, he will experience more fluid friction. If a jet aircraft or if an airplane is traveling faster, thereby it will experience more friction. Okay. Second thing was the nature of the fluid. Nature of the fluid also influences the friction. Say, for example, if the viscosity is more, yes, Ibrahim, you particularly tell me as you were present in the previous class. Tell me how viscosity influences fluid friction. Yes, if a fluid has higher viscosity, so thereby its friction will be more or less,
Less.
right? No, less. Good, and vice versa. So nature of fluid, particularly, we did learn about the viscosity of the fluid. Viscosity, by the way, Aisha, it basically means the resistance offered by a fluid, uh, basically resistance to flow. Okay, now by viscosity, basically we means that it's the resistance of a fluid to flow. Getting it? It's the resistance offered by a fluid. Like it will be resisting to change its position, change its shape, basically. So that is viscosity. Okay, so if the viscosity is more, so thereby the friction will be more. Further, we have learned about the shape of the object also. So if the shape of the object, particularly, let's say it is streamlined shape like this. If it is having a streamlined shape, so it will experience less friction. It will experience less fluid friction. So that is something which we had discussed in the previous classes, and we did some questions. Were some questions left to do? No, okay, we did discuss all the questions by the way, Ryan, right? Okay, let's start this chapter then. See, that was a quick revision. Okay, Aisha. Although, if you still face some difficulty in that, you can let me know. We can arrange an extra class for you then. Okay. Uh, mhm. While the chapter will be revised, there again we can discuss your doubts. So in the chapter sound, we'll be learning about different things. Particularly in this chapter, we will learn about how the sound travels. Okay, how the sound is produced. Uh, then we will learn about some special things about sound, like why certain people have a loud voice, why females have a higher pitch sound. Right now, we will learn about certain things about the sound, particularly when a sound will be said to when a uh, like what's the difference between noise and music, how are they different, okay, what exactly is the difference between that. Okay, so such are the things which you will be learning in this chapter. Okay, and these are particularly the major topics around which our discussion is going to rotate. So then first we will learn about how the sound will be produced. Okay, now how it is produced by any object, whether it be a non-living object or whether it be in the case of an organism, how do they produce sound. And further we will learn how does the sound propagates, how it travels through a medium, or we will also learn that does it require medium, and why in the vacuum the sound will not travel. Further we will learn about the frequency of the sound, loudness of the sound. Okay, how the loudness of the sound is determined, right? Okay, further we see that like certain animals in the night would be barking, would be making noises. uh, so the thing is that particularly we see that foxes or like dogs or coyotes, they would be howling, they would be barking at night. Why? They, although they are nocturnal animals, as some of them are nocturnal animals, right? But the thing is that certain animals can hear the sounds which our ears cannot. Getting it, Aisha and Ibrahim? Particularly, we know that like cats and the dogs, they can hear higher frequencies. Okay, now Then mice also, they can also hear higher sounds. Getting it now? So they can also hear the sounds of higher frequency can be heard by them. Okay. Particularly if you were to talk about some of the special animals like bats, dolphins, or rats or the mice. What is special about all of them? Yes, Harim, how are you?
I'm fine. How are you?
Yes, I'm good. See, we have started this chapter right now. Sound chapter has been started, Harim. Okay. So you also continue from here. All of you turn your cameras on in the class. Aisha, Harim, all of you. Ibrahim, are you outdoors?
Yes, sir.
See, if someone is outdoor, then they can keep their camera off. Okay, no issue in that. Okay. Hmm. But if you are indoors, make sure to turn your cameras on in the class and also make sure to sit at a proper and a quiet place. So, what are we saying that? In the chapter, Harim will learn about what is sound, how the sound is produced, does the sound require a medium to travel? Okay. We see that certain people, particularly the okay, no issues. Harim, if you can connect the camera, then no issues. Yeah. So we see that why the like we see that the males have a louder voice now. Males usually they have a loud voice. Females they have a higher pitch sound. So what is the reason behind that? Uh, which part of the human body produces sound? We will learn about that. Okay. Then we will learn about what is noise and what is music and how are they different from each other. Why a certain type of sound is considered as noise and certain type of sound is considered pleasant to your ears. It appeases the ear. Okay, no? So what is how are they different from each other? We will also be learning about some special and some interesting things. Yeah, like dogs or the bat or the mice or like dolphins, they can hear the sounds of very high frequencies. Okay, no, they can hear the sounds of very high frequencies. Okay, that is one thing. So they will be sometimes behaving unusually, like during earthquakes certain animals will behave unusually. Many times we see that some animals would show some unusual behavior before an earthquake. Ever observed that? Ever heard about this or read about this? Uh, like like it is said that certain animals would leave their homes, or certain animals would move to a higher ground, or higher ground, or if they are toward a water body, so they will move towards move to a safer place away from the water body. Uh, they will show abnormal routine. They will show some abnormal routine. So what could be the reason behind this? Uh, Particularly in the rats, also particularly in the snakes, so some unusual behavior are observed in them. And it's not like a new thing. Many thousands of years ago people have done studies on the unusual behavior shown by animals, particularly during the time of earthquake or some other natural disaster. You guys know that when the earthquake waves travels on from when the earthquake waves would be traveling through the plates, through the tectonic plates, so it will produce some sound. The earthquake waves, as it travels through the tectonic plate, it produces some sound. But do we hear that sound? Yeah. The vibrations that are produced within the earth surfaces, as those vibrations will travel via the tectonic plate, do we hear that? Do we ever
No.
hear the no? Getting it now? So although we don't hear that, but we can hear the shaking, like we can experience the shaking of the building, or we see that ground would be rupturing apart, etc. But the sound waves that are produced, they are not audible to our ears, but it can be audible to the ears of certain animals. Uh, so earthquake waves will be audible to certain animals, but not to humans. So what is the reason behind that? So we'll be learning about all those things in the class. Getting it, guys? So based upon all these things, our discussion would be one more important thing. We'll be particularly learning about the structure of the human ear. Okay. Can you guys tell me, like, Tell me this thing. Ever thought about like what is the role of this ear lobe, ear pinna, this whole structure? You just think about this. Like I have this question, although we are going to discuss this. What could be the role of the outer part of the ear? Anyone?
It's to
If
like
it,
protect our ears from dust and all.
not a very specific reason. The main reason, the main function of this now will be learning this. Like uh, interestingly and funningly, someone I asked this question to a kid some time ago. So interestingly, what he said now, he said that um, okay, Harim, go get your charger, get the charger of laptop. See, so why I asked this question to a kid a long time ago. So think of what answer he would have given me. So the kid told me that 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 God gave us the earlobe and the ear pin on the outer part so that we can wear glasses. How else we would have been able to wear glasses if the outer part of the ear was not there? Okay, but the main function of the of that outer part of the ear would be that it would be helping to collect the sound waves. Okay, no, it would collect the sound waves, and it will further help in absorption of the sound wave and will further send it to the ear canal, and there the sound wave will vibrate the eardrum and all that, which we are going to learn in the later part of the chapter. That is the thing. Let's just start the class then. So talking about sound, so we say that sound is a form of energy. Simple. Sound is a form of energy that will be produced whenever an object would be vibrating. Whenever object of certain parts in the human body will be vibrating. Okay. Now the question comes that it's a form of energy, so it must be traveling in some way from one place to another. It has to travel. So we'll be learning about that also, like how does it travel and all that. But the first thing is that the cause of sound is vibration. The major cause of the sound is vibration. Okay, now. So first thing is that sound is a form of energy. Then question is what is the cause? So cause is vibration. Cause is the vibration of an object. So take the example of this drum here. As the membrane of the drum will be vibrating here, so the air molecules that are above the membrane, what about that? Will that also not vibrate? The air molecules, will there be no movement in that? Yes, Harim, Ibrahim, and Aisha.
There will be.
Of course, they will be no, right? So just take a look at this animation first here. As the object will be vibrating, look at the air particles here. They're also vibrating. And aren't they vibrating in a very unique fashion, in a particular fashion? They're vibrating, right? Observe this animation here. So one obvious thing is that whenever an object would be vibrating, or like for example, when we place the hand on the loudspeaker, does it not move? Ever seen how this moves? Forward, backward, like this. So the vibration of the object creates disturbance in the nearby air molecules also. Air molecules are simply we can call them as particles also for convenience in understanding. So thereby what happens whenever an object will be vibrating, it will create disturbance in the air particles. And the air particles will also start to vibrate. And because of the vibration of the air particles, sound will be produced. The sound will be produced. Basically, what will happen? The air particles will be colliding against each other. Collision will take place against each other. And because of that, sound is produced. So far, two things we have seen that sound is a form of energy. Okay. Sound is a form of energy. Now, and further, we are seeing that it is caused due to vibration of an object. And the vibration of object sets some disturbance in the air. Okay. The vibration of objects sets changes in the air particles and the air particles starts to vibrate and produces sound. Okay, air particles, so we can simply say particles. Okay, now because if you were to say just air particles, thereby we will be limiting the sound only to the air. Because the sound can be produced under the water also. Okay, and it is produced in the solid also. So sound, we will see that it can travel via different mediums, whether it be solid medium, whether it be liquid, or whether it be the gaseous medium. What is common about all these medium is that all of them have particles in them, whether it be solid particle, liquid, or the gaseous particle. But the question is, will sound be able to travel in the vacuum?
No.
No, because sorry, in the vacuum, since there is no medium, so thereby sound will not be since there will no be a particle in the vacuum. Hence, as there are no particles in the vacuum, so thereby sound will not be produced in vacuum. Getting it? So that is the reason. Further, important thing to be learned about the sound is that, like, if something has to travel from one place to another, it has to travel in some ways, right? Like for example, what we know about light travels in the form of waves now. Getting it? Light is a form of energy that also travels in the form of waves. Suppose if you were to take, if this is, let's say this is a pond or something, and if you were to drop a stone in this, so ripples are formed or not? Water ripples are formed like this. Yeah, getting it? So that energy, which basically what happened here, the energy, as you put that a stone into it, as you have dropped 1 minute. Yeah. So as you have thrown a piece of the stone into the water body, thereby it sets some ripples in the water body, and in the form of water ripples, the energy transfers, it travels into the water body. Okay. Similarly, when we are vibrating an object, are we not setting some disturbances into the air? Like you can think of it in the similar manner, as you have thrown a piece of stone there, so it led to some disturbance in the water. Earlier water was calm, it was not moving, it was calm. But as you put a stone into this, it set some disturbances into the water. Are you able to relate with what I'm trying to say? Similar to that, you can think here, as you are beating a drum, or as you are speaking, or someone is playing a guitar, or someone is hitting at the tuning fork. So it is setting some disturbances into the air, all of these musical instruments, right? So whether it be string instruments like guitar, sitar, etc. Okay. Anyone knows the name of this instrument? I forgot the name of this one. What does this instrument is? Obviously, like this is a string instrument.
I think that's Veena.
What do we call this?
I think Veena.
No, that is not Veena. I'm sure like this one is not Veena. Veena has a different structure, by the way. Anyone? I think it has a small name. I'm forgetting the name of this, by the way. I think, do we call this harp, 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 or something like that?
Yeah, hard.
Harp, no? Yeah, correct. Anyways, so whether, yeah, I was trying to discuss, or relate the example of this with this here. So as you throw a piece of a stone into the pond, so it changes, it leads to some disturbance into the water body, and it travels in the form of the waves. The energy travels in the form of the waves here. Similarly, what will happen? Also in this, the waves will stop after some time. Similarly, as you are hitting an object, so thereby, due to the vibration of that object, it will change. It will produce some disturbance into the medium, right? It will lead to some disturbance into the medium. So thereby, the air particles will start to vibrate, and after a certain time, the vibration of the object of the air particles will stop here. Okay, that is one thing which is happening. Further, sound will be produced via different types of objects, different type of musical instruments. These are some of the musical instruments: string, wind and brass, percussion instruments. So the string instruments will be basically producing sound due to the vibration of the string used in them. Wind and the brass instrument will be producing sound as the air would be moving across it now. So thereby, as the air would be moving across it now, so thereby the sound will be produced in it. Okay. Similarly, percussion instrument, basically by the striking of the instrument, the sound will be produced. That is one thing. So sound can be produced in different ways. One of the important role of sound is that it helps us to communicate with one another. Okay, now it helps us to communicate with one another, which is a very important thing in our daily life. Okay, now without sound, it will be very difficult to communicate with one another. Okay. So how do people who are not able to produce any sound, or their sound box is defective, so they have to communicate via the sign language, right? That is one thing. A question like, how do the humans actually produce sound? So we humans have a larynx, or the voice box. Remember, also called as the Adam's apple, right? So this is the voice box present in our throat. Okay, and this opens up into the windpipe actually, right? So in the humans, we have a voice box, also called as larynx box, which is present in the throat of the person. Basically, on the upper side of the windpipe, it will be present. Okay, it is not separate from the windpipe; it is present in the windpipe actually. Okay. Now, larynx has two vocal cords, which are separated from them. These structures, these white structures that you are seeing here now, these are called as vocal cords. Also, take a look at this structure. This one over here, they are the vocal cords, and there's a narrow gap between them, narrow slit between them. This is the narrow slit between them via which air can pass. So what happens here? As we will be speaking now, like as the lungs will be throwing the air out of the windpipe, so it will pass through the slit. It will pass through the slit, and it will make the vocal cords vibrate. So the vocal cords will vibrate, and because of the vibration of the vocal cord, sound will be produced. Getting it? How the sound is produced? Yeah. So due to the vibration of the vocal cords, sound is produced. Furthermore, like in the chapter Age of Adolescence, we did learn about few basic things about it. As we have learned that when at a particular age in the life of a teenager, what we see that the shape and the size of the larynx changes. In the boys, particularly, what happens? It becomes more thicker. Right? Now, like the thickness in the girls also increases, particularly in the boys, it is more thicker. Okay. Also, we see that different peoples have different voice qualities. Why? Because no two people in the world can ever have the same type of the voice, the natural voice. Like if they are doing a mimicry or something, that's a different thing. Okay. So the thickness and the tightness of the vocal cords, okay, the thickness and the tightness of the vocal cords are different for different people. Hence, the voice quality of different people are different. Particularly in the male, it is seen that the vocal cords are longer. It is about 20 millimeter, and the females, it is about 15 millimeter. Particularly, if you were to talk about the children, children have a very short vocal cord. The length of the vocal cord in children are very short. Hence, we see that the voices, their quality and their type are always different in women, men, and children. Have you guys ever met any two people who are having the same type of voice? Usually, That's a rare condition. That's a rare situation. Okay. So when we basically speak, the air passes through the voice box. And because of this, the larynx will be vibrating, and hence it produces the sound, right? And that we hear as our voice basically. Hope this much should be clear to everyone. The next thing is like how the sound will be moving through through a medium. In order to understand this, I want to tell you guys about one important thing. Like there are two types of waves. We need to understand about what is waves and uh, and what are the types of waves first of all. Okay. See, if you were to talk about waves, like waves have different meanings in geography, and in physics it has different meaning. Like if you were to talk about waves in physics, so wave basically is kind of a disturbance in a medium that will carry the energy from one place to another. What is wave? A wave, we can say that it's a disturbance in a medium, right? It's a disturbance in a medium that will carry energy from one place to another. Are you guys able to understand what I'm trying to say here about wave particularly? Yes, Harim, Aisha, everyone.
Yes,
Yeah.
sir.
So before we understand how the sound will be traveling, an important thing to be discussed is the wave. And there are two types of wave which we are going to discuss. Waves. So about waves, I say that it's a disturbance in any given medium. So it is a disturbance in a medium, okay, that will be carrying the energy, that carries the energy without the movement of the particle or object. Let us understand what I'm trying to say by this definition. Say, for example, when I am speaking, so my voice would be reaching to the person sitting in this room or in front of me or some or nearby. So is my vocal cord going over there, or just the energy that I am producing due to the vibration travels there? Yes.
Could you please repeat?
My question was, no, when I am speaking, so I am able to speak because of the vibration of the vocal cords. So the person sitting nearby me, let's suppose, or person sitting next in the next room to me, so he or she will be able to hear me because consider two options here. First option, I am saying that the voice, the box or the larynx travels to them, and that's how they hear the sound. A second one, and the obvious thing is that, is it that the energy is being carried from coming out from my voice box to them?
The second one.
The second one, obviously, right? So energy is being carried without the movement of the particle or the object. Or when you hit a drum, so only the energy is traveling through the medium now. The drum does not travels from the medium from one place to another, obviously. So how that energy is going from one place to another? It is by some disturbance in the medium. So the medium will be disturbed, but that does not mean that the particle or the source of that energy also travels from one place to another. Suppose, for example, light is the energy. It's a form of energy, right? Suppose the sunlight. Let's take the example of sunlight. So the source of sunlight is sun, obviously, and sunlight is a form of energy that travels in the form of waves. Right now, so is the sun traveling to the earth, or basically the sunlight is traveling in the form of waves by creating some disturbance into the air, by creating some disturbance into the medium? Although you don't get to see that disturbance, but there's disturbance into the into the medium into in which the sound will be traveling. particularly as we're talking about the sound, so sound will also produce some disturbance into the medium in which it will be traveling. Getting it, everyone?
Yes, sir.
So I was saying that there are two types of waves. First one is mechanical wave. Mechanical wave. Another one is the transverse waves. Now, mechanical waves are those waves now, like in which now the medium will be required. In which medium will be required for an object, like in the mechanical wave, medium will be required. But in the case of the transverse wave, medium is not required. So, for example, sound is an example of a mechanical wave that requires medium, right? Sound requires a medium to travel. Getting it? That is one thing. If you were to talk about light, as we know that light, irrespective of medium, it will travel. Light travels through the vacuum also, and vacuum does not have vacuum is not a medium. So light is an example of a transverse wave. Light travels in the form of the transverse waves, while sound travels in the form of mechanical waves. Okay. Further, just take a look at this animation here. That will clear your doubt here. Take a look at this. In this transverse wave, what is happening here? In this transverse wave particularly, what is going to happen? Take a look at this case here. In this, the red dots that you're seeing, you can think of them as the particles here. Think of them as particles. And this is the direction of the wave. This is the direction in which the wave is traveling. So you are seeing that the motion of the particle is perpendicular to the direction of the wave here. Take a look at this animation, that will clear your doubt further. Right? So energy is traveling from its source to over here. Energy is traveling in the form of transverse waves, in which you're seeing that these are the particles of the medium. The red dots that you're seeing, that is jumping over here. Okay, and it is jumping perpendicular to the pathway of the uh, wave here. So this straight line is showing you the direction in which the energy is being transferred, in which the wave is traveling basically. And look at the particle of that medium. The medium could be air, it could be water, it could be solid, etc. And look at how the particles of the medium are jumping. Are they not jumping perpendicular? They are moving perpendicular to the direction of the, like this is the direction, the direction of the wave. The wave is moving like this, and the particles are jumping like this. Are you guys able to relate with what I'm trying to say?
Yes, sir.
Okay. So this is something which we'll be learning in detail later on, by the way. Just take a look at this one also. Okay. Like this is the football fans, and this is how like they're jumping like this. Okay. Also, just look at how it appears as if this is a wave in the ocean, a wave in the water body. The wave also moves in the falling manner, right? The wave also moves in the falling manner, isn't it, guys?
Yes, sir.
That is one thing. But say, for example, if you were to take a spring and if you were to move it in the falling manner, so we are seeing that the spring is the particles of this here, like you can just think of this as a medium. So in this, we are seeing that the particles of the medium are traveling parallel to the direction of the wave motion. They're traveling parallel to the wave, direction of the wave, here. Like the wave is traveling in this direction, and the mediums are also traveling in this direction only. Like sometimes they will come closer, sometimes they will go farther. Sometimes they comes closer, sometimes they gets farther away. So that is the case of the longitudinal wave, in which the particles would be traveling in the form of compression and rarefactions. Like sometimes they would be very close to each other, so that will be called as compression. And sometimes they'll be far away from each other, so that will be called as rarefactions. So in the form of rarefactions and compressions, the particles of the medium, if it travels in this manner and they are parallel to the direction of the wave, like the wave is traveling parallel like this. I mean to say the wave is traveling in this manner. but the particles are traveling like this, for example. So that is the longitudinal waves. This will be revisiting in the next class. As of now, why we have discussed it? We have discussed is this just to tell you guys that sound travels in the form of longitudinal waves. Now observe this one here. The direction of the sound wave is this. And what you guys can tell me about the motion of the particles? Tell me, are they jumping up and down or are they moving like this? Forward and backward in the form
They're
of
moving straight.
compression reaction. Yep. So can we say that their motion is parallel to the direction of the sound wave? Tell me, Harim, Ibrahim, and Aisha.
Yes, it is.
Yeah, that is one thing. So we are learning that sound travels in the form of waves, particularly travels in the form of longitudinal waves. Further, we know that it always requires a medium to travel. So for sound to be transmitted from its source to our ear, a medium is required. Right? So in the space, there is no medium. So how you guys think, like, how the astronomers would communicate with each other in the space without there being a medium? Suppose if they have to go out of their spacecraft, so then how they will be communicating? So there they will be.
Language.
Repeat again.
Sign language.
Yeah, they can use sign language also, good. But suppose if they are very far away from each other, let's suppose. So let's say they are not visible to each other properly. Then in that manner, how they are going to communicate? As there is. Mhm.
They have devices in their helmets.
Yeah. So there are some special devices. Okay, no? So in their headsets, special devices are fitted. Particularly those devices would be using the radio waves, because radio waves can travel in the vacuum also. So with the help of the radio waves, they would be able to communicate with each other. So in their headsets, special devices would be fitted together, and that will convert the radio waves into the form of sound. That is the case. So sound cannot travel in the vacuum as it does not have any particles. So hence, since no particles will be vibrating, so how can sound be heard, and how can it travel? Because it requires particles, and due to the vibration of the particles only, sound can be transmitted from one place to another. Further, different mediums of propagation of sound are air, liquid, and gas, and the speed of the propagation means the movement or the traveling. So the speed of the propagation of sound in different mediums will be different. Why? Because in certain mediums, the particles are closely packed. In some mediums, particles are loosely packed and are apart from each other. So we will see that sound would be traveling, like sound through water will travel 4 times faster than through the air. If the speed of the sound in the air is x, so thereby in the water it will be 4x. What could be the reason? The simple and obvious reason is that the particles of the air are farther away while the particles of the water are closer. So thereby, energy will be quickly transmitted to the nearby particles. Hence, the speed of sound is more in water as compared to the air. Is that much clear to everyone so far?
Yes, sir.
Yes.